Alrighty, so let's get going. I'm Kate. I'm the regional director with Woodworks located here in Oregon. I cover Oregon, Southern Idaho, and Hawaii, which is an interesting range of a lot of different states with a lot of different uses of wood that you see. But Oregon is certainly, a major user of wood products when it comes to our buildings, and there are a lot of reasons for that. And we'll talk about some of those reasons today. But just a little bit more about me. I'm actually from Colorado, but came out to Oregon a long time ago for graduate school. I studied wood science and structural engineering at Oregon State. I practiced as a structural engineer for several years with KPFF, and then eventually went over to the construction side and worked on the construction side for a little while, where I actually built the building that I had designed. So that was interesting. It was a light frame wood building. And then eventually I came over to Woodworks because I had a lot of experience with all different types of wood frame structures and engineering and construction experience as well. Anyone who doesn't know who Woodworks is, we're a nonprofit organization. We're funded by the Forest Service, the Softwood Lumber Board, and Forestry Innovation and Investment to basically just act as a free source of technical support for anyone working on wood frame structures. So if you need any help with your wood frame structures, you can reach out to me anytime. I'm kind of like the Ask Siri of wood structures. Any questions you have, any role you play, if you're an engineer, architect, developer, contractor, we help everyone. So reach out to me with your questions. As long as they're about wood frame structures, I can probably find a solution for you. We're also partnered with a lot of manufacturers all across the country, but we're not a marketing group. We're actually required by our funders to be very neutral when it comes to our manufacturer, or when it comes to just any wood products in general, because the Softwood Lumber Board represents everyone that produces lumber, and the Forest Service represents all forest landowners. So we go out of our way to be very neutral, and you'll see that in a lot of our presentations. And maybe at the end of this, we can talk a little bit about, how does that neutral technical support actually support all of these people that are funding us and helping us. So today, our conversation is really all about sustainability. And I don't think you can go to any conversation coming from the construction industry about sustainability without seeing this chart. It's been talked about probably too much at this point, but it's not changing. The fact that we are the largest producer of greenhouse gases across all industries, we've been talking about it for a while, and it just doesn't seem to be changing. So when we look at our operational energy and our embodied energy combined, or the embodied emissions coming from our industry, we see that we produce 40% of all global emissions. And a smaller portion of that is that embodied carbon. That's the emissions associated with the, extraction, processing, transportation, construction with all of the materials we use. May be smaller, but it's this large upfront cost that we pay every time we build a new building. And it does represent a significant portion of overall global emissions, being 15% of all global emissions. So it's still something that we need to be looking at, and it's something that's getting a lot more attention from our industry. I mean, basically, we've decided that we need to build better. We need a better way to build, but I would argue that we already know how to build better. Our understanding of building science, our understanding of materials, basically everything we base our decisions on is above and beyond really what's required in our codes or what's required in our green building certification systems. It's above and beyond what most buildings are built to. Our understanding of how to build is above and beyond the way we build. And I think the question is, why is that? And how can we better address that? Ultimately, the reason why it's hard for us to change as an industry is because there is so much diversity in our industry. Every building is built by a different developer or a different owner. And those owners range from everyone from single family homeowners to public entities, federal governments, state governments, city governments. There are nonprofit organizations that own buildings. There are tribal nations that own buildings. There are small minority women-owned emerging businesses that own buildings. There's so much diversity in all of these buildings that are owned, and a lot of diversity in why they're owned and why they're built and how they're used. So, really, there's just so many layers in our built environment that we have to be able to figure out how all those layers influence sustainability and address all those different layers and able to actually advance sustainability. And so that's where you see a lot of talks really boiling down to this triple bottom line, this idea of people, planet, profit all being part of sustainability. You also see this as the three pillars of sustainability. So social, environmental, and economic in those pillars is also something I've seen, but it's all saying the same thing. It's saying that, we can't ignore the influences that the economy has and that, social influences have on sustainability, and just look at the planet, because doing so is going to ultimately hurt the people with the least access to economic support. Like in the end, we're going to leave all those people behind. So everything we do, has this sort of attachment of like, it has to be affordable and it has to be able to serve the people who are using that building or the people who are building that building beyond just being good for our planet. If we wanted to do what was good for our planet, we would just stop building buildings altogether. But we have this social need for housing and this social need for schools. So, there's a lot acting on these considerations. If you haven't seen this report came from ULI. So this is the materials movement, creating value with better building materials. And they talk through a lot of these influences that I just mentioned. In fact, in this report, ULI identifies 5 goals of sustainability that they say should be weighed in material decisions all across stages of the life cycle of a building. And they boil that down to climate health, human health, social health and equity, ecosystem health and circularity. And then they discuss the major drivers that are sort of influencing decisions that developers are making or that can help to incentivize better decisions that developers are making in terms of their material choices as they relate to those goals all throughout the life stages of the building. And one of the major influences they did talk about is this idea of this growing market demand that we've seen for a long time for certified green or healthy buildings. And so these building certifications really act as an assurance to the end users that certain best practices were used in the construction of the building. And really, it's acting as a label that end users can recognize, because a lot of those users, they don't have the understanding on their own to be able to look at a building and say, yeah, this was totally built sustainably, right? So it's creating a label that end users can recognize and then allowing developers to use that label to drive demand for their buildings. And so that gives developers an economic means and also an incentive to take more steps towards sustainability. But if you read that report that ULI mentions, they also mention a lot of other influences that are acting on decisions and a lot of new policies and regulations and incentives that are, causing or urging developers to take more sustainable actions, even if they're working outside of those certification systems I just mentioned. So, this includes some of the climate policies we're seeing, the build clean and buy clean policies, especially Cal Green is a very new policy adopted that actually requires construction projects of a certain size in California to demonstrate that they are meeting certain embodied carbon goals. There's also a lot of new incentive programs coming out, like the Inflation Reduction Act, which doesn't just apply to the construction industry, it's for all industries across the US. We're seeing an emerging carbon credit market, again, not just in the construction industry, but across industries. And then just to throw this in there, it's not in the paper from ULI, but the US Forest Service also gives out wood innovations grants. So a lot of opportunities to, find ways to use more sustainable and renewable materials in buildings beyond just those incentives that come from certifications alone. So there's really a lot more movement towards doing whatever we can to really influence change. So we could spend all day probably talking about any one of those policies, but that's not what we are here to talk about today. What we're here to talk about is why wood. So how does wood fit into this? And I'm actually going to call out ULI on one part of their paper, which is just that the only examples they use are mass timber buildings, and really the sustainability benefits that come from mass timber, most of them are coming from the fact that it's made of wood. Wood is a really cool and renewable material. So I'm actually going to start from the end of the life cycle and work backwards, because I think circular economy is kind of like the most important consideration for why we should be considering all types of wood products in our projects and not just mass timber. Mass timber is a great new innovative material and it's beautiful, but it's not the only wood product out there. So let's talk about that. The principles of a circular economy actually apply to all stages of the life cycle, not just the end use. So these include, the beginning, where we're trying to reduce overconsumption of our natural resources. That's one of the principles. And then in addition to that, we want to reduce waste. We want to design for long life and reuse. And then we want to use materials that are easy to repair, reuse, or recycle, with the ultimate goal of keeping those materials circulating in the economy as long as possible. So wood products and mass timber products are part of this large category of engineered wood and timber. And this category of products that's made from all different parts and pieces of the log, whether it's solid sawn lumber, veneers, sawdust, or wood chips, it allows us to efficiently use our forests and efficiently use our logs. So it's not just about using smaller diameter logs that are faster to regrow, but it's also enabling us to use more of each log. There's only so many rectangular pieces of lumber we can cut out of a log, or so much veneer we can peel off a small log. And so by having these other products, our OSBs, our I-joists, our LSLs, and our particle boards, that enables us to take the remnants of what's left and also turn that into usable products. So I was looking at a paper that Dovetail recently wrote. They're a consulting group that helps both landowners and end consumers make more sustainable decisions. And they reported that today's sawmills are capable of utilizing over 99% of each harvested log. 90% of that is directly used in wood products, and then another 10% or so can be burned for energy recovery. And the major difference between burning wood for energy and burning fossil fuels for energy is the fact that wood is part of its own natural carbon cycle. So, trees are consuming carbon from the atmosphere as they grow, and then that carbon can be released at the end of the life cycle. That's going to keep occurring over and over. This is carbon that's cycling in and out of our atmosphere, regardless of how we interact with the carbon. So when we take wood and we burn it for energy, what we're doing is we're just working within that cycle, and we're using the carbon that's re-entering the atmosphere, either route that it takes to produce energy as it leaves the forest. That, compared to fossil fuels, is different because fossil fuels take millions and millions of years to store in the ground. And once we release them, which wouldn't have happened if we hadn't done that, they would take another millions of years to put back in the ground. So, the more fossil fuels we release, the harder and harder it will be to actually bring carbon levels back down, because again, those fossil fuels took millions of years to store in the first place. And so one major thing you're seeing across our energy or industry is this goal of trying to figure out how to, put that carbon somewhere. All that carbon we're releasing from burning fossil fuels that can't be just put back into the ground. And that's where wood products also come into play. So wood products intercept some of the carbon that's leaving the forest at the end of its life, and they store carbon in the wood products or in our buildings for an extended period of time. as long as we keep it stored there, it then allows the next generation of trees to sequester excess carbon from the atmosphere. And that excess carbon is excess carbon that we've been releasing from fossil fuels if we do everything right. And then, the ability to break down wood into smaller pieces of wood and then put it back together into larger pieces of wood also enables more circularity within our wood industry. So, in theory, we can take and keep that carbon circulating through our economy for a much greater period of time because we have such a large range of different wood products that we can create with these smaller pieces of wood. And it's not just the carbon in our wood that's circular, that energy that is produced by burning wood, so whatever is left after we get as many products out of the log as we can, that energy can circulate back to our mills and give them the energy they need to, process the next logs in the chain. And then any leftover energy can also circulate back onto the grid and power homes or nearby buildings. So there's a ton of circularity just in the wood products industry because of the nature of wood and the fact that it's a renewable material. But that all said, mass timber does have advantages. Mass timber is usually built with much more simple connections and no finishes. So it's easier to disassemble a mass timber building than it is a stick frame building. Mass timber is a lot more valuable too. It just costs more than light frame studs do because there's not a lot of material in a light frame stud. So all of that work it takes to go into a building and reclaim all of this material has a better yield in a mass timber building than it would in a light frame building. And so there's more economic incentive there for someone to actually go through and dismantle a mass timber building. And so one cool thing we're seeing more and more mass timber teams do, like the team that worked on Apex Plaza, is actually design their building and their connections so that all of the connections are mechanically attached, and they design them to make them as easy as possible for disassembly. Now, one team actually reached out to me and asked me what I would recommend as being, important considerations for designing for disassembly. And honestly, one that I haven't heard talked about as much is the idea of communication. Because if I was an owner or if I was a contractor and I was looking at a building and considering whether or not it's worth taking it apart, I would want to know what I'm getting out of that building. And if I had an inventory of every single timber member in that building that I could stand to recover, that would make that decision a lot easier. And also if I had, detailed information about every single connection and even how the team may have designed it for disassembly, that would make that decision even easier again. And so one cool thing about mass timber, especially prefabricated systems, is when we're working on those buildings, we're creating these digital twins. These digital twins are used in the computer-aided prefabrication process. So manufacturers need these to be able to CNC cut all of the members. But once we have this digital twin, it's really easy to make that inventory I just talked about, or to make some sort of documentation that can be used to communicate to those future owners. So, a lot of good reasons behind mass timber as well, but all of our wood products are important. So the last concept of circularity that we haven't really addressed is this one, this idea of designing for long life and durability. And this is actually one of the biggest concerns or reasons that I hear from developers that are deciding maybe not to use wood. So, is that a reasonable concern? And should we be looking at durability? Well, to address this, I want to look at a study that Foreign Tech Canada Corporation did. This is a little bit older. It was done back in 2004, but it found a lot of great information that we can draw from as we're having these conversations. So what this study did is it looked at 270 buildings that had recently been demolished. 105 of them are non-residential buildings. That's what's shown here. And the buildings ranged across a bunch of different age classes. So they were anywhere from less than 25 years old to over 100 years old at the time that they were demolished. In addition to looking at the age of materials used, Foreign Tech also the age of the building and the materials used. Foreign Tech also surveyed the building owners to find out why they demolished the buildings, because that's important. If we find any sort of correlation, we need to know if there's also causation there, and that it's not just a correlation for some other reason, right? So what they found was that the majority of reasons actually fell in one of these three topics. Either there was changing land values, so maybe this was a struggling restaurant in a location where there was a lot of demand for apartment buildings. So that's a change in land value. Or the building did not meet current needs. So maybe the building was too small for the occupants, and instead of building an addition, maybe there wasn't a good way to add on to the building, they demoed the building and rebuilt it. Or there was a lack of maintenance on non-structural components. So the facade, the interior finishes were just degrading, and rather than renovate the building, the owner decided they just wanted to rebuild it. So what we see here is that there's no significant relationship between the structural system and the useful life of the building. So none of these reasons had anything to do with the structure or the material used in the structure. And the ultimate conclusion of this study was that maybe we shouldn't be, using a goal of long life and durability to select our materials, but rather we should be determining the realistic service life or useful life of our building, and then using that to make decisions based on the environmental impact of materials we're using in our buildings. So in other words, maybe we shouldn't use high impact materials or non-renewable materials in buildings that we don't expect to be used for a long period of time. Because doing that, like concentrating our efforts on reducing those impact of those shorter life buildings, is ultimately going to have a greater benefit because embodied carbon is an upfront cost. And there actually are already standards that tell us how to do this. So these two standards here, the ISO standard and the CSA standard. CSA is the Canadian Standards Association. ISO is the International Standardization Organization, some combination of those words. But this is the US version pretty much, even though it says international. Both of those standards are written to give a framework to designers to do what I just said, to establish the useful life of a building and then make decisions based on what that expected life is. So one interesting correlation, remember I said correlation and causation are different, is that among the buildings, if you look at the age classes, the majority of buildings in the higher age classes were wood frame structures. We can't look at this and say that that means wood is more durable than steel and concrete, because again, there was no connection between the structural material used in the building and the reason for demolition. But what we can conclude from this is that wood buildings are capable of lasting for over 100 years. They're capable of being durable. And also that in this area of Canada, which is very forested, Canada as a country is extremely forested, they probably started building with wood long before they started building with steel or concrete. So, if you think about Oregon, we are a very heavily forested state. Most of our cities were actually built around mills and around timber to begin with. And we also started building with wood long before we started building with other materials. So if your developers are ever asking this question, or if you are a developer and you want to just see how a historic wood building has fared, you can go into any number of buildings across our state, and a lot of our historic buildings are timber framed buildings. Now, a quick side note, because this wasn't supported in the investigation of that study, and it's just me speaking anecdotally from my own experience practicing as a structural engineer here in Oregon, where there are a lot of those old wood buildings. I've noticed through my career that there is a lot more drive among owners of these wood buildings to kind of bend over backwards to retrofit them. They were willing to put a lot of money into retrofitting the buildings. And one building in particular, I'll always remember, it was this old grain elevator, this timber framed grain elevator in Carlton that was kind of cobbled together without any building permits by just rural farmers working in that area, that the owner loved so much that I spent years redesigning retrofits for that building because they wanted to preserve the building. They wanted to change how it was being used and actually open a winery or a wine tasting room. And so they were really interested in finding a way to preserve the building. I eventually moved on in my career because I wanted to go into construction. So I left engineering before that project ever moved forward. But I do know that they did eventually retrofit at least part of that grain elevator, and you can go do wine tastings. So if you're ever in Carlton, go stop by that grain elevator. I spent a lot of time crawling through it. So anyway, that's anecdotal. Again, not part of the study, no evidence I have in hand to say anything about that beyond just my stories. But there are a lot of studies that have been conducted on biophilia and healthy buildings. And biophilia essentially is that weird connection I just talked about. It's this connection that humans have to biological materials and to nature. And I won't talk through all the studies in detail other than just saying that there's a lot of them. So for example, Australia, in this study, they surveyed 1,000 typical Australian workers. And they found that those workers who were in workplaces with a higher proportion of visible wood generally felt that they were more connected to nature. They had lower stress levels, they had higher concentration, and they generally had improved overall moods. Similar studies have also been performed on students. British Columbia did one where it was a little bit more of a blind test, like trying to make it more clinical. What they did was they measured stress levels and recovery rates on students before, during, and after taking a test in different rooms. So one room had wood finishes, one room didn't. One room had plants and wood finishes, one room just had plants. And they found that the rooms with wood finishes did foster lower stress levels while the students were taking tests, and they allowed for the students to recover faster. So they had faster measured recovery rates after the test. Woodworks has also conducted our own study on the business case for biophilia and for mass timber in general. We looked at the cost of buildings and a range of buildings, to be more specific, across multifamily and office buildings. I will say that this was done kind of during COVID, so it's hard to separate cost data from these and separate out the impacts of COVID. So it's kind of hard to use them for the cost side. And obviously office buildings aren't in as high of demand after COVID as they used to be. But there is still a lot of quantitative and qualitative information just about the lease-up rates for these buildings. And the qualitative information as well was really powerful in demonstrating, just through storytelling, that the owners were seeing higher quality tenants sign up for the buildings, that those tenants were signing up for longer term leases. And then quantitatively, again, that those tenants were willing to pay higher rent premiums. So there was a lot of evidence to show that, mass timber could be used in combination with, of course, other strategies. It's not just the timber, it's the design of these buildings to really draw in more tenants and more interest in the buildings, and to create a better business case for biophilia in general. But I think one thing that makes the biophilia talk easier with developers is just the fact that we have a lot of built examples of these timber buildings. So, a picture is worth 1,000 words, but a tour is worth even more. So if you can take your developers out and go walk through wood buildings, or if you are a developer, go out and visit these buildings, because you can see all different types of buildings built with all different types of wood materials, and really understand the impact of what it's like to be in those buildings or to work in those buildings. It's more, it's a more profound impact than what I can convey really in a presentation. But I do want to say that there is an interesting argument for for warehouses that I really like, or at least what I see. This building is Janicki Industries warehouse up in Washington. They are an aerospace manufacturer. Um, and when I look at this building, to be honest, I see all sorts of potential. Like you could have a wedding reception in this building. It could be an event hall. It could be a community center. It could be a grocery store. It could be an open office building. And when I think about this building, I start to think more about a lot of those timber buildings that I retrofitted or did retrofits on in Portland, because we do have a lot of timber framed industrial buildings that are now being used as office buildings or as, you know, restaurants and stuff. So I think there's a lot of potential, especially for warehouses. Okay, so if you've noticed, we have been moving backwards through the life cycle. So continuing on that journey, we are in the occupancy stage of our buildings and talking about the benefits that wood can bring during occupancy. And another great benefit is just adding to the thermal performance of the building. So, you know, that's really just a function of the R value, or the thermal resistance of wood, which is much higher than steel or concrete or stucco or brick. So, you know, the second we start replacing, you know, concrete tilt-up walls and metal walls or metal roofs in these warehouses, we're automatically improving the thermal envelope of that building. And in warehouses where they're usually not conditioned, that small improvement can have a huge impact on anyone who works in that building. It just makes the atmosphere better. And then in buildings where we do condition our buildings, it improves the, you know, thermal performance and the energy use in that building. So it can help to bring down those operational emissions. But if you look at this, wood is not as good at doing that as insulation. So again, that's why we shouldn't ignore our other wood products. Light frame construction is super economical, and simply substituting a wood stud into a steel stud wall without changing anything else can have a huge impact on the overall R value and the overall thermal performance of that wall. And so, you know, we've done all these measures of this and have a ton of information on how much you can improve that thermal performance just by that one simple switch. And you know, light frame wood construction, wood studs are one of the most economical types of construction you can build. So this is a really good option for anyone. All right, so let's talk about labor. So we're moving on to backwards in our timeline. Now we're on the construction site. What are the health benefits? What are the social benefits on our construction type or on our construction site? And for this, I think mass timber really has a lot to offer. You know, when we're looking at prefabricated systems, and mass timber isn't the only prefabricated wood product. So there are other systems. There's modular wood buildings. There's panelized light frame buildings. But when we're looking at these fabricated buildings, because that fabrication is done in the factory in a more controlled environment, there's a lot of labor benefits, both in the factory and on the site. Factory workers benefit from, again, that more controlled environment. There's less unknowns, there's less unfamiliar conditions that can cause safety problems. And they also have the benefit of, you know, always working in the same location in terms of like where they choose to live in their commute. They also have more stability in their employment and their pay in general. So there's a lot of benefits to moving more of this labor off-site where it's less controlled. It's a harder, harsher environment into a more controlled and conditioned environment as well. Now, on-site, mass timber, again, because that labor is moving into the factory, it does allow for smaller crews during that timber installation. So instead of having this crazy ballet of all of these different site workers on site at a time, who are all working around each other or above each other and might be using equipment that could be dangerous to the people around them, what we have is a much less congested site with just a handful of people that can all see and know what the other person is doing. And there really isn't a lot of equipment besides just the crane, just the hoisting equipment. So job sites that are installing mass timber tend to have a lot less safety incidences. And those safety metrics for people who do a lot of mass timber construction like build up all over time. And for any contractors who are listening in, safety metrics are definitely used when selecting a contractor, or they're used for builders' risk insurance premiums. So, using mass timber and like some of these prefabricated systems to help with those safety metrics is important. The faster construction that mass timber offers also helps reduce overall builders' risk costs just by having a shorter construction schedule too. And then finally, because most skilled work is done in the factory, we can also use more entry-level laborers in order to construct these buildings on site. And so if you think about that and you think about like maybe a project like this one that's in a really remote location, this is the National Forest Supervisor's Office in Kamiah, that's the word, Idaho, which is basically in the middle of nowhere, or so I'm told. I've never been there. But what's cool about this building is the contractor, who it was his first time doing CLT, was able to build this building with a crew of 6 people. That crew came from just 30 miles away, and a lot of them were actually tribal workers. So they participated in the Nez Perce Tribal Employment Rights Office program. And that really just shows how mass timber can actually enable more opportunities for that site labor component. And we are seeing, more and more mass timber buildings that are partnering up with co-bid partners, especially here in Oregon, so that they can actually train other smaller businesses that don't have as much access to be able to work on these mass timber buildings and get hired to work on them. They can open the door for them, because again, it's not hard to install. It's also not that hard to design. Really, what's hard about it is just finding out what it is, because it is just such a new material. So that brings us full circle to the beginning of our project life cycle. We're now to the harvesting or extracting and manufacturing of our materials. And at the beginning of the presentation, I did walk through a lot of the efficiencies we see for wood. Those efficiencies do enable us to have less embodied carbon associated with our wood products, but wood is also capable of storing carbon as well. So let's talk about that. When we're looking at steel, concrete, glass, aluminum, a lot of those other materials that are made from minerals that we take out of the ground, those minerals all have to be processed, usually with a lot of energy, to actually change their chemical composition in order to create steel, concrete, glass. Cement in particular, which is a component of concrete, is made from limestone, which has to be converted from limestone to lime. And that process not only takes a lot of energy, it also releases carbon dioxide as a byproduct. Wood is also processed. It goes through a chemical process, but not by humans. Trees do this chemical process. It takes a lot of energy from the sun to actually turn carbon dioxide and water into wood, which is essentially what you're seeing here. And then instead of releasing carbon dioxide as a byproduct, they sequester it, and then they release the oxygen as a byproduct. So that whole process is done for us by trees, and gives wood a very unfair advantage over other materials when it comes to life cycle assessments, in a lot of different ways. So not only do we not have to process trees, so there's less embodied carbon involved, we really just transport them and dry them, but they also store that carbon. And that carbon that's stored is called biogenic carbon when we're looking at our life cycle assessments. Now, biogenic carbon in our buildings, in our life cycle assessments, is calculated based on just that chemical equation I said. So the amount of carbon that's actually in wood is based on that conversion of carbon dioxide into carbohydrates for use as a building block in woods. And if we look at that equation, wood ends up being about 50% carbon by dry weight. And wood weighs about 30 pounds per cubic foot dry. So our buildings have about 15 pounds of carbon stored in them for every cubic foot of wood that we use in our buildings. It's actually pretty easy to calculate how much biogenic carbon is in our buildings. But there is one more step, because that carbon that I just calculated is solid carbon. And solid carbon has a different molecular weight than carbon dioxide. So if we convert that solid carbon back into the amount of carbon dioxide that was sequestered to store that carbon, we get that every pound of carbon in our buildings represents 3.67 pounds of carbon dioxide that was removed from the atmosphere. So that's the full calculation for figuring out how much embodied or biogenic carbon is actually in our buildings. And then we track that separately from embodied carbon. So when you're looking at a wood building versus a non-wood building in a life cycle assessment, in the wood building, what you're seeing is the embodied carbon emissions in this red arrow. And that, includes all of the emissions from, going into the forest, removing the logs, building those roads, transporting the logs. It also includes, all of the manufacturing, drying the wood, any additional transportation, any power used throughout those stages that didn't come from burning wood, since that is a neutral emission. It also includes, power used to create or grow seedlings, and power used to take those seedlings out into the forest and replant the forest. So that's all included in embodied carbon in the red arrow. And then our biogenic carbon is the green arrow, and that's included as a negative. So it's a negative emission or a storage, and it helps to offset the embodied carbon emissions on the top side, that red arrow. So again, wood has a lot of advantages in life cycle assessments, and it just comes down to like that science behind wood, and just the fact that wood is a renewable material and part of its own carbon life cycle. But I think even though biogenic carbon is easy to calculate, what really throws us off, or what really makes it hard for designers to understand, is this requirement. So this is in the ISO document that controls how we are to do a life cycle assessment for our buildings, because the point of a life cycle assessment is to have a standardized way of accounting for carbon. So this ISO document is what controls that. You can see it referenced in the bottom corner. I don't like reading numbers at people, if you notice that, but it's down here. But this basically says that we can use biogenic carbon and account for it as negative when it enters our product system when the wood originates from a sustainably managed forest. So the question that I always get is, what does that mean? What is a sustainably managed forest, and how do we define that? And I'm going to talk through that pretty quickly because we're pushing to the end of our time, but I had to hide a lot of slides to dial this presentation down. So please ask questions. And I do have more slides to talk about if they come up in questions. So for this, I want to take a step back and really draw a parallel between the construction industry, the built environment, and the forest. Because I think we understand the built environment a lot better than we understand the forest, and so it's easier for us to just understand all the influences in our own industry. I was actually at the Structural Engineers Association of California's annual conference last week, which was in Portland for some reason. I don't know why they always do it in a different state, but I managed to sit in on this talk from a professor at Colorado State University that was kind of calling us out on how we measure the possible economic impact of an earthquake on a community, specifically in our efforts to determine who gets how much funding for post-earthquake emergency recovery. And what they were pointing out was that when we do that measurement under our current methods, what we do is we look at individual buildings and we look at the value of that building and the assessed value. And then we add up all these assessed values of these buildings and we say, okay, the areas with the highest assessed value of buildings stand to have the greatest economic impact because earthquakes damaged buildings, and so it's going to cost more to fix all these higher cost damaged buildings. That's kind of the premise there. The problem is when you start, taking a step back and expanding your boundary conditions of what you're using for that assessment, what you start to notice is a lot of different trends across communities in terms of not just the value of the building, but also the income of the owners. And that actually has a considerable influence on the economic impact of an earthquake. And so what this presentation looked at and concluded was that lower cost buildings tend to be, closely populated in lower income communities. And when that happens, those lower cost buildings are usually lower cost because they're older buildings. They were built before current codes, or and they usually haven't been seismically retrofitted, because seismic retrofits that are voluntary cost money. So lower income owners are less likely to have done that. And then also we use relative cost of remodels to actually trigger mandatory seismic retrofits. So even our mandatory seismic retrofits kind of work top down, not bottom up. And so you actually end up with a lot more damage to these buildings when they are concentrated in lower income communities. And then it takes those communities a lot more time to rebuild those buildings, even if the overall cost was less, because they are a lower income community. So if you think about the cost of the displacement of the community and the fact that they've been offline and unable to work for that much time, it adds up over time, all those costs. And so the point of this is that by only looking at the building, by having that tight boundary condition, and then using that to measure something across a larger area, that boundary condition prevented us from seeing all of the actual influences. So let's take a big step back and look at our forests. When we are talking about carbon in our forests, what we're really talking about is the forest influence on the atmosphere. The atmosphere is a global entity. It doesn't care where carbon is entering or exiting it. The carbon levels of our atmosphere are actually the net emissions of all of our forests around the globe. But that's not the only thing we're looking at when we're specifically looking at forest sustainability as it relates to atmospheric carbon in our building life cycle assessments. So the other thing we have to consider is, what is our buildings' influence on the management of our forests and how those forests actually interact with the atmosphere. So our boundary condition, to be reasonable, should really consider the largest area of forest land, so we get the largest contribution to our atmosphere that we can reasonably influence or control. And that's going to give us the most accurate measurements. So when you look at papers from organizations that are looking at forest sustainability globally, what you often see is forest sustainability metrics reported or analyzed at the country level. And the reason they do that is because you see distinct differences in the sustainability of forests across countries based on each country being a governing body. So all of those policies, all of those incentives, everything we said was influencing our developers, those also act on a nationwide level on our forest landowners. And that same diversity that we see across our building ownership, we also see across our forest land ownership. So our forest land ownership in the United States includes forest land owners across the public and private sectors, everyone from single-family forest owners, community trusts, tribal nations, city, state forest owners, colleges own forestry for research, or forests for forestry research, so on and so forth. Large corporations also own forests, but there's so much diversity that we can't really take a one-size-fits-all approach to actually supporting forest sustainability. And since we're running out of time, I'm going to skip forward to a slide that hang on one second, catch my place. So when we're talking about forest sustainability and economics, what we end up seeing is that there is a gradient. It's a layered approach to sustainability nationwide. The way sustainability is kind of managed and driven in the United States is very layered. So we have monitoring and inventory programs that are nationwide that were established over 120 years ago. Those actually measure everything across all of our forests. Those feed into the development of best management practices, which we have over 70 colleges of forestry across the nation that are studying forest science and actually developing best management practices to be used in forestry. Oregon State University is a great example and a leader, not just in the country, but also worldwide. They're one of the top 20 colleges of forestry among 3,000 colleges looked at around the world. So that's pretty cool in our own backyard. But again, just one of 70 examples across the nation. So a lot of people are working on forest management practice development. Those feed into our laws. So just like our building codes, our laws are constantly evolving to keep up with these best management practices, but our laws can't outpace the economic means of our ownership. So, the people who are governed by these laws have to be able to afford to follow these laws. And so to enable owners that can take more steps, we also have certification programs in the forest side that also closely relate to the certification programs we have on the built environment side. And then, at the bottom end of that spectrum, the most important thing that we need to not overlook when we're measuring the carbon impact of our forests across the country and actually looking at economic influences is land conversion, because land conversion is permanent deforestation, and it occurs largely when a forest landowner cannot economically support themselves with their land as a forest. So maybe they parcel off some of their land and sell it to an owner that might not want to keep it as forest land, or maybe they decide that they're going to change their business model and have some other business that does support them better economically. The thing about our forest laws is that it doesn't control what private landowners use their lands for. They only apply to commercial timber harvests. So actually getting ahead of deforestation in the United States, where we have so many forest laws all across our nation, really involves making sure that our owners are economically supported and that there is a reason to keep their land forested. So with that, I'm going to actually open this up for questions because we are out of time. But like I said, I have a lot of other slides to talk about for any questions that there are.
Thank you so much, Kate. That was just an amazing amount of information and really, really great. We got a couple questions about AIA credits. So Kathy, do you mind jumping in really quick and just talking through the process? Is it a certificate of attendance? Do you just register everyone quickly?
Did those questions just come to you then, or?
Yeah.
Okay. When you registered, it should have given you the option to say whether you are an AIA member and put your AIA number. All of those are going to be automatically sent to National, and National will have them on your transcript. If you are not an AIA member, it may or may not have asked you if you wanted a certificate. If it did ask and you said yes, I'll do it. If it didn't ask and you aren't an AIA member, I will do it. If you specifically want one and you are an AIA member, then email me. Hold on, let me get that in the and let me know that you also want a certificate. Otherwise, it'll just automatically register you through AIA. Does that make sense?
Yep. All right. If you have any other questions, it sounds like Kathy's happy to
Feel free
answer
to
them.
email me at that.
All right. Well, we are at 5 o'clock, so I would invite those who need to jump off to go ahead and jump off. But let's go another 5 minutes if just to do some Q&A if for those who would like to stay. And I did not get any questions in the chat, so how about if I invite you to just unmute and ask your question?
Hi, Jean.
Hi, friends. Thank you, Jean, for putting on your camera. Great to see you.
I wasn't sure if we were told to not because I came 5 minutes late. Maybe it was
No,
10
we
minutes.
just I just turned mine off so that all focus was on Kate, but
That's what I did too once I got on there and I was like, oh, it's me and Kate, and that's it. So technical question.
yeah.
I don't actually have any. I just turned on my screen and you said hi.
Oh, okay.
Oh.
Excellent. I mean, Kate did such a great job of covering so much in a really, I thought, digestible way that
Ellen,
maybe everyone got it. Yeah.
sorry, apparently I did not ask for AIA numbers.
Yeah, you didn't.
All right, well then there's my email. I will send out an email to everybody who registered and they can get back to me with what they want. So just watch for my email.
Thank you, Kathy. All right. Any questions for Kate? I don't know, Kate. I think you might have just nailed it.
All right.
Everybody,
Well, if
everybody's
questions-
feeling very informed. Yeah.
if
I did
questions do. Oh,
I did want to comment. As soon as you said the Carlton elevator, I was like, oh my gosh, I have so many photos of it. And so I tried to dump like one of my last photos when I was out there, just to say, yes, this is a thing. And then when it wouldn't take the photo, because it told me that, no, you can't enter things here right now. I thought the chat didn't work. So
yeah,
apparently the chat does work.
I spent a lot of
does
time
work.
as building those two towers. They're pretty crazy because they were just like built as they were needed. So there's all these like scabbed on
Yeah.
parts. It's really cool building. So
Scab together.
So Kathy, I know that maybe folks don't have questions now, but they might come up. So this is recorded and it'll be on the AI Oregon Events Archive for
Yes.
second watch.
Program archive, yes.
Program archive. So definitely recommend if you want to take a look at the slides and listen in again, it's going to be there for you.
all right. I would add since there aren't any questions, just that there are a lot of resources and folks can also reach out to me as well. But we do have a ton of resources on life cycle assessment and how the standards require you to handle biogenic carbon, as well as information about how each individual life cycle assessment tool accounts for biogenic carbon. We also have a new series of comparative life cycle assessments that are becoming available. So the first building has already been assessed. That's a building in Denver, Colorado called Return to Form. And the team actually designed that building that it's a 4B building, a multifamily mass timber structure. They designed it 3 different times, one with light frame construction, one with mass timber, and then once with concrete. And then they did full life cycle assessments and full cost assessments. So that's in this series. And then there are 3 more buildings in the works as well, different size buildings and different types. We also already had an existing study like that for an office building in Denver. So more and more information on full life cycle assessments is becoming available because these are a heavy lift for designers to do. And we recognize that. And then also there's a lot of information available for designing with mass timber efficiently and also designing with wood efficiently, because even though it's a low impact material and can store carbon, we still want to use materials efficiently. So a big step we can all take as designers is just use the materials in our buildings more efficiently, and that will go a long way as well. So
yeah, that's a great point. Thank you. It sounds like Woodworks just has an amazing library of resources. That's really great to know and understand. So thank you so much for sharing that. And then just for those who are still here, the AIA COTE Green Champion Summit is actually going to be on October 7th at the new PDX area, you know, the new terminal expansion, where this is just like the perfect setup for such a lovely building that really incorporated that to heart. So we're gonna dig in a little deeper to that project in October as well. All right, well, thank you so much, everyone. Really appreciate you joining us today. Thank you so much, Kate and
Thanks.
Elisa, for helping us find Kate. And it was great to have you here today. And maybe you're going to be able to join us in October, and we can see you in person at the event.
Yeah, that would be great. I'll have to connect with Elisa offline and get more information about that.
Yeah. Oh, it
Definitely.
looks like Kathy dropped information about the Green Champion Summit. There's going to be a lot of promotion coming. That was sort of just a spoiler alert.
Perfect. I already
notice.
opened the link.
All right. Well, thank you so much. I hope everyone has a great night. Appreciate you joining us.
Bye. Thanks, everyone.
Bye, thank you.
Bye.